Hello friends, in the Collegiate-Physics classes, you all are welcomed. This is series of lecture number 5. In lecture number 4, we have started discussion about the properties of perfect elastic collision in one dimension. In lecture number 4, we have deduced these two equations V1 and V2. M1 is the mass of first particle, M2 is the mass of second particle. The velocity of first particle is u1, the velocity of second particle is u2. When they make head-on collision along a straight line, then after collision we have already deduced the velocity of the first particle v1 and the velocity of second particle v2. Now to explain more different cases, we have taken the first case if M1 is equal to M2 is equal to M. That is, the mass of two bodies are equal. They are making head-on collision along a straight line. Then what will be their velocities after the collision? In this equation 2 and 3 and 4, M1 is equal to M2. That is, this term will become 0 and this term will become U2. That is, V1 will be equal to U2. Similarly, this term will become 0 and this term will become U1. So, V1 and V2 will be calculated. Its interpretation is that V1 is equal to U2 and V2 is equal to U1. That is, if the two bodies make head-on collision and the collision is perfect elastic, then the two bodies will interchange their velocity after the collision. V1 is the velocity of a first body after collision and this is equal to U2. U2 is the velocity of second body before collision. Similarly, V2 will be equal to U1. Further, if we assume that U2 is equal to 0, U2 is equal to 0 means second body is at rest and the first body is making head-on collision, the second body is at rest, then what will happen? U2 will be 0. That is, the velocity of the first body will become V1 is equal to U2 and U2 is equal to 0 because second body is at rest. So V1 will be equal to 0, that is the first body will hit the second body, the first body will become rest, and the second body M2 will begin to move with V2 is equal to E1. This body will begin to move with E1 velocity. This is very interesting thing. The second body is at rest, the first body makes a head-on collision, the collision is perfect elastic, then the first will come to rest and the second will begin to move with the same velocity E1 as that of the first body. Now, the case number 3 will be like this. Now, case number 3. Suppose that M1 is greater than M2. The rest situation is same. That is, the two bodies are making head-on collision along a straight line. After collision, their velocities are V1 and V2. Now we have assumed that M1 is very large in comparison to M2. That is, the velocity of first body is, the mass of first body is very large and the mass of second body is very small. In this situation, this M1 is very large with respect to M2. So M2 will be neglected. So M1 by M1 will be equal to E1 and this term will be neglected because M2 is very small and M1 is very large. So this term will be negligibly small. So V1 will be equal to E1. V1 will be equal to E1. Similarly, from equation 4, this M2 is very small. So this M2 will be neglected, this M2 will be neglected. So V2 will be equal to 2E1 minus U2. This will be the velocities of two bodies after collision. The case will be very interesting if we assume that U2 is equal to 0. That is, the second body, which is lighter bodies, that is at rest, and the heavier body makes head-on collision. Then what will happen? V1 will be equal to E1. That is, the velocity of the heavier bodies after collision will remain unchanged. V1 will be equal to E1. The velocity of first body is equal to E1 and E1 is the velocity of first body before collision. So that there will be no change in the velocity of the first body. But the velocity of second body, which was at rest before collision, its velocity will become 2E1. That is twice the velocity of first body. इसको हम ऐसे भी समझ सकते हैं, एक कार खड़ी है, इधर से एक हेवी ट्रक आकर इसको धक्का मारता है, तो जो ट्रक है वो अपने वेग से चलता चला जाएगा और जो कार खड़ी थी उसका वेग ट्रक के वेग का दुगना हो जाएगा और वो आगे फेंका जाएगी. This is the very interesting result of this perfect elastic collision in one dimension. Now the last case of this question. M1 is less than M2. That is, the lighter bodies the last case is case number 4, in which M1 is very small, M2 is very large. That is, the first body which is going to strike the second body is of lighter mass. In this case, M1 is very small, so this M1 will be neglected. V1 will be equal to minus E1, and this term will be neglected because M2 will be, this M1 is neglected, so it will be equal to 2U2. So V1 will be equal to 2U2 minus E1. Similarly, V2 will be equal to, this M1 is neglected, so this will become 0, and V2 will be equal to U2. Again, further case will be applied. If U2 is equal to 0, then V1 will be equal to minus E1 and V2 will be equal to 0. This means, suppose that there is a heavy vehicle of mass M2, this is a truck, and a light vehicle, suppose a car is making head-on collision with this truck, then what will happen? The velocity of this car will be equal to minus E1, and velocity of this truck will be equal to 0. That is, this car will make a collision and it will rebound back, but the truck will remain at rest. These are the different various interesting cases of perfect elastic collision in one dimension. So today we will stop this point, and this question is already completed. All the different cases had been discussed. Thank you.